Hello everyone. In this video, we are going to learn the Kirchhoff's laws or rules, okay, which is very important. There are two rules. One is Kirchhoff's current law, other is Kirchhoff's voltage law. Okay, so before understanding the KCL and KVL, okay, that is Kirchhoff's current law and Kirchhoff's voltage law, you should understand two terms. Okay, first is what node, and second one is what a loop. What do you mean by node? When we talk about node, it is a point where more than two conductors meet. Okay, where the more than two conductors meet. So let's take this point is there. Here one conductor is there. Here another conductor is there, and here also one another conductor is there. Okay, so this point A is considered as what a node. Node is a point where more than two conductors meet. Similarly, second point, mesh or loop. It is a closed path of an electrical network. You can see here A, B, C, D, A. Okay, here one cell is there, resistor R1 is there, resistors R2 is there, and there is a closed path. Okay, this is also called as loop. So this is called as what? A mesh or loop. Now let's discuss first law, that is Kirchhoff's current law. It is also called as KCL, also called as what? A junction law. According to this law, the sum of currents at the junction, the algebraic sum of all the currents at the junction is equal to 0. Okay, you can read the statements. You can see the statement. It states that the algebraic sum of the currents at a node is equal to 0. That is summation of I is equal to 0. Okay, or what other statement is there? Sum of currents entering the node is equal to sum of currents leaving the node. Okay, so we can see this one. Okay, let's take a node is there. Here I1 current is entering, I2 current is entering, I3 current is leaving, I4 current is leaving. So what is this law? Sum of all the current is equal to 0. If you take entering current as positive, so I1 is entering, right? This is the point at a node A. Okay, you can see I1 is entering, I2 is entering, okay, I3 current is leaving, and I4 current is leaving. Entering current you can take positive, so you can write a plus I1, okay, plus I2, and leaving current you can take as negative. Okay, so minus I3 minus I4 is equal to 0. This is only KCL. Okay, if you can move minus I3 minus I4 to that side, so what will get? I1 plus I2 is equal to I3 plus I4. So you can see clearly that I1 and I2 are entering current and I3 and I4 are leaving current. So sum of entering current is equal to sum of leaving current. For MCQ questions, they may ask you in the exam, okay, what is the significance of this law KCL? So the significance is that it explains the law of conservation of charges. That charges cannot be created nor be destroyed. Okay. Next, we talk about Kirchhoff's voltage law. Okay, are also called as loop law, KVL. Kirchhoff's voltage law, KVL. You see the statement. According to this law, okay, sum of IR products is equal to the algebraic sum of EMF present in various branches of a closed circuit. So let's consider a closed circuit. Okay, where resistance R1 is there, R2 is there. Let's take a cell of V volt is there. Okay, now V or anything you can write A, B, C, D. You can see this is a closed path. A, B, C, D, A. Okay, so in loop A, B, C, D, A. Okay, when you move from negative to positive, okay, now what happens? We have to consider the sign. You can see you can take a afterward sign. So what we are saying plus V, right now. Okay, now whenever current flows through the resistors R1 plus to minus, there is a drop in potential, right now. So afterward sign is what? Minus I into R1. Similarly, I current passes through R2, so plus to minus, afterward sign is what? Minus. So minus I R2. Okay, any other resistor is there? Any other EMF is there? No. So that is equal to 0. So you can see the sum of IR product, sir. Okay, current and resistance product is equal to the algebraic sum of EMF. So minus I1 R1 minus I2 R2, you move to that side. So V is equal to what? Plus I R1 plus I R2. Okay. We can also say the sum of all the EMF and potential in a loop is 0. Delta summation of V is equal to 0 also. Okay, that is also fine. So this is a Kirchhoff's voltage law, or sum of IR products. Okay, current and resistance product is equal to the algebraic sum of EMF. So as there is only one EMF V volt. Yeah. So V is equal to IR1 plus IR2. Okay. Yes or no? I hope you understood the Kirchhoff's current law and Kirchhoff's voltage law. Thank you.